Welcome to the Bodhi Academy. My name is Amisha Palacio, and today we are going to continue with our chapter of class 8, chapter 10, sound. So previously in this video, we understood what are vibrations and that vibrations further lead to the sound production. So now vibrations are back and forth motion of any objects. So therefore it means that if there is no vibration, there will be no sound that will be produced. Further, then sound is produced by the voice box or the larynx that is present over here at this part. The small part right here at our neck which vibrates when we speak is the voice box or the larynx. Then we saw that sound needs a medium to travel. So this then we saw through different experiments wherein we proved that sound cannot travel in vacuum. A place where the air is sucked out and you try to produce a sound, it won't travel or you won't hear any sound. Further, we saw that sound cannot be also heard or produced in liquids, but sound could travel from solids. That is, we saw different experiments of activities in which we tried to hear or we tried to make sound travel through solids, and it did travel through solids. Further, we learned about the eardrum. So, eardrum is a thin stretched membrane at the end of the narrow canal, that is the eardrum. So, eardrum is like a stretched rubber band. Say you have a balloon, say you stretch it and you spread it. That is what how eardrum is. So, now how do we hear this sounds? So, sound vibrations. So, these sound vibrations, they make the eardrum vibrate. Okay. So, when this eardrum vibrates, it further sends these vibrations to the inner ear, and from the inner ear the signals then go to the brain, and that is how we are supposed to or we are able to hear. So now moving ahead, today we'll continue with the rest of the chapter and we'll look into few terms that are related to sound, that is amplitude, time period and frequency of a vibration. Now we have learned that the to and fro motion of an object is known as vibration. So this we already know. When an object is moving back and forth, that is known as the vibration. Now this vibration or this motion, say you have a pendulum which is moving from back and forth, back and forth. So in that case, that motion of back and forth, it is also known as oscillatory motion. So this motion is also called the oscillatory motion. You have learned already in earlier classes about the oscillatory motion and its time period. So the number of oscillations per second is called the frequency of oscillations. Now, the number of oscillations as in how many times, say you have a pendulum, the pendulum moves back and forth, back and forth. So every time it moves out, comes back, that is one oscillation. So how many such oscillations take place in in per second, that is known as the frequency of a oscillation. So now frequency is expressed in terms of hertz, and its symbol is Hz. So a frequency of 1 hertz is 1 oscillation per second. So it means that one oscillation that happens per second has a frequency of 1 hertz. So now if an object oscillates for 20 times in 1 second, what would be its frequency? So that would be 20 hertz. Now, you can recognize many familiar sounds without seeing the objects producing them. How is it possible? So now say I'm sitting here and say I can currently hear maybe the sound of the fan. I'm not even looking at the fan, but I know that is the sound of that fan. So how is that possible? So these sounds must be different to enable you to recognize them. So now we already know how the sound of a fan comes. You can hear a very, not a very loud, but a fine hearable sound when you turn on the fan. So in that case, your brain has already registered that it is the sound of the fan. Have you ever thought what factors make them different? So now say you have a Okay, let's take an example, this simple example. Now we have electric bikes and we have petrol bikes or diesel bikes. So when you try to differentiate, electric bikes are they don't have much loud sound. They come very, at a very low peak sound they travel. But if you look at diesel bikes, they travel at a very high pitched sound, right? So now, how, on what factors do we differentiate between these two sounds? Okay, both are sounds, but somewhere the electric bike sound has a lower pitch, whereas the diesel bikes have a slightly higher pitch. So now amplitude and frequencies are two important properties of any sound. So now frequency we know. Frequency we saw that it is the number of oscillations per second, and that is known as frequency. So now what is amplitude? So amplitude is basically, it is the measure of the height of the wave. So now say, okay. So say this is, okay, this is my wave. Okay. So this part, the height, okay, the height of this wave is known as the amplitude. Okay. Or in other words, what we can consider is, say you have a pendulum here. This is its initial position. Okay. So say at once it displaces up till here. Okay. Second time it goes a little more further, that is up till here. So this loudness, okay, this will create, now see, if it goes from here till here, maybe its loudness, okay, not a pendulum, consider a bell. So the bell inside has a round structure that produces the, so how much, with how much intensity and force it goes and hits is what defines the sound of the bell. So here amplitude, it is defined as the loudness of the vibrating particle of the medium, and it is defined from its mean position, that is its actual position, to where it is getting displaced, or it is defined as the height of a given wave. So now, can we differentiate sounds on the basis of their amplitudes and frequencies? So loudness and pitch. Okay. So the loudness of sound depends on its amplitude. Now say, what I said here earlier was that about the bell, right? So now the loudness is defined by this amplitude. Say this structure over here, round, it goes and hits the wall very slightly. So in that case, the sound will be less. Okay, so we can say that the amplitude is also, amplitude with which it is hitting the wall is also very low. Therefore, the sound produced is also less. So the loudness of a sound depends on its amplitude. When the amplitude of vibration is large, the sound produced is loud. So more the vibration, more is the sound that is produced, or more the amplitude of the vibration, then more is the sound produced. When the amplitude is small, the sound produced is very feeble. Feeble as in it is very slight or very faint that you can hear. So now compare the sound. Okay. So to understand these terms, see here. What it says is that loudness of sound is proportional to the square of amplitude. Okay, so what it says here is that loudness, okay, of any sound, it is directly proportional to the square of the amplitude. So now say an sound is given, sound has a unit of decibel. Okay, so see here, it has a unit of decibel and it is given by dB. Okay, so now say your loudness is approximately say 3. Okay, so now 3 decibel. What will be your amplitude? It will be 3 square, that is 9. So it says that loudness is directly proportional to the square of the amplitude. So higher the loudness, more will be the amplitude, or more is the amplitude, louder will be the voice. Okay. So now moving ahead, the frequency determines the shrillness or pitch of a sound. So now what we said, frequency is the number of oscillations that take place per second. That is the frequency. Now this frequency also determines the shrillness or pitch of a sound. Now shrillness, when we can say, or pitch is a simpler term to understand. We talk in low pitch and we talk in high pitch. So now say you have, okay, you have a drum. See, there's an example here, simple example. Say one person is hitting on a drum, the other one is whistling. So now out of these two, which one is low pitch and which one is high pitched? Obviously the whistle that is there, that will be high pitched. So that is that its frequency will be very high. So in that case, the sound is very shrill and it will have a high pitch. Now whereas if you look at the drum produces a very bass like sound, a very, like, rough kind of sound. So that is a low pitch sound. So in that case the frequency of vibration is also low, and therefore it is a low pitched sound. So now if the frequency of vibration is higher, we say that the sound is shrill and has a higher pitch. That is, as we said in the case of whistle. If the frequency of vibration is lower, we say that the sound has a lower pitch. See now here, see, a bird makes a high pitched sound, whereas a lion makes a low pitched roar. The lion's sound may be louder than that of a bird, but it still has a low pitched roar. Whereas the bird makes a sound that is very, it won't be very audible to everyone as compared to the roar of a lion, but still it is a high pitched sound. Now, audible and inaudible sounds. Now, when we say audible and inaudible sounds, now there are certain sounds that we can hear. Okay, certain sounds we won't hear. Say you at the least you can hear a whisper, somebody whispering something to you, you can hear it. Below that whisper, now you won't be able to hear. And say there's an inaudible sound, like there is something very loud, extremely loud, that beyond that you won't be able to hear. Now on what basis is that range defined? So we know that we need a vibrating body for the production of sound. Can we hear the sound of all vibrating bodies? No. In some cases the vibration is there, it is present. It is not like it is not vibrating. It is vibrating, but it is vibrating at a very low pitch, or low momentum is there, or low oscillations are there. In that case we won't be able to hear that sound. So the fact is that the sounds of frequencies less than about 20 vibrations per second, that is 20 hertz, cannot be detected by human ear. So now what they are saying is that any sound which has a frequency of less than 20 hertz, or it has oscillations of only 20 vibrations, in that case below that 20 hertz we won't be able to hear. Now say a object produces a sound with a frequency of 15 hertz. That frequency or that sound we won't be able to hear. So such sounds are called as inaudible sounds. Sounds whose frequency is below 20 hertz, such sounds are called as inaudible sounds. Then on the other side, sounds of frequencies higher than 20,000 vibrations per second, that is 20 kilohertz, they are not audible to us. So we can basically hear between only 20 to 20,000 hertz. Beyond 20,000 and below 20 hertz, we won't be able to hear. So the ones beyond 20 hertz are inaudible voices to a human ear. Then noise and music. So now how do we differentiate between something noise and music? Now sound is a sound. Now how do we define that this sound, particular sound, is a noise and the other one is a music? Music as in it is pleasant, and noise as in it is not pleasant or it is disturbing us. We hear different sounds, different types of sounds around us. Is the sound always pleasing? Does the sound sometimes cause discomfort? Some sounds are pleasant to hear. whereas some are not. So some sounds we like to hear. Now say you are stuck in the traffic and you can hear that honking sound and all. That is not pleasant sound. We don't like that sound. Now say opposite would be you're playing some music at a very loud volume and all, but you're enjoying it. It is not causing any discomfort or it is not irritating you. Suppose construction work is going on in your neighborhood. Are the sounds coming from the construction site pleasing? Of course not. Do you enjoy the sounds produced by horns of buses and trucks? No. So such unpleasant sounds are called as noises. So sounds which we don't like or which we think are unpleasant to us are termed as noise. So in the classroom, if see we have so many students and all of them are talking, so that is also a noise. On the other hand, you enjoy sounds from musical instruments. Musical sound is one which is pleasing to the ear. So now sound is unpleasant. Pleasant sounds would be musical sound. So sound produced by a harmonium is a musical sound. That is, you like that sound. Your ears feel pleasant to hear it. The string of a sitar also gives out a musical sound. But if a musical sound becomes too loud, would it remain melodious? In some cases, yes, because nowadays people like DJs, like loud voices. In that case, yes. But something which really goes unbearable and something which is not pleasant, yes, it would start to become a noise to us. Now, noise pollution. You have already known that about air pollution. Presence of unwanted gases and particles in air is called as air pollution. So, similar basis, presence of excessive or unwanted sounds will be known as noise pollution. So, major causes of this noise pollutions would be what now? Crackers, machines, construction sites, loudspeakers, then some explosions and traffic honks and sounds like that are the sources of noise pollution. What sources in home may lead to noise? Obviously, our televisions, our cell phones, high volume, and our kitchen appliances like our mixers and all that we run, that annoying sound that comes, which is very loud. Then we have even coolers, which some of them make sound. Even air conditioners, they also contribute to noise pollution in our homes itself. So now, what are the harms of noise pollution? Obviously, the presence of excessive noise in the surrounding will cause some kind of impairment or some kind of defect into our ears. Other than that, other than the ears, it can also lead to lack of sleep. Some people or most of us don't get sleep if there's a lot of noise happening in the background. So that is that you'll have lack of sleep. There will be hypertension, that is your blood pressure will rise, anxiety and many more health disorders. Measures to limit noise pollution. To control noise, we must control the source of noise. So how can this be achieved? For this, silencing devices must be installed in aircraft engines, transport vehicles, industrial machines and home appliances. So now to control noise pollution, one thing they can do is silencing devices. You introduce them into all the things that produce very loud, unpleasant sound. So how can noise pollution be controlled in a residential area? All noisy operations must be conducted away from any residential area. So now if there's something very loud, some machinery is being banged and things are being broken, so such kind of things should be done away from any residential area, any society or any apartments where people reside in. Noise producing industries should be set up away from such areas. So they are saying that noise producing industries, they should be set up away from where people actually reside. In residential areas or nearby, you shouldn't have such noise producing industries. Use of automobile horns should be minimized. Unnecessary honking on the roads, or even just because you're annoyed at somebody, just don't honk for absolutely no reason. So TV and music systems should be run at lower volumes. Trees must be planted along the roads and around buildings to cut down the sounds. So what happens when you plant a tree in front of your house? Say you have a very, that tree Actually, what it does it blocks that sound. It becomes a wall like in between the sound that is coming to your house or to your building. So that is why it is said that you should also plant more trees to reduce noise pollution. So that was it for this chapter. In this chapter, we saw sound is produced by vibrating objects. In human beings, the vibration of the vocal cords produce the sound. That is, the vocal cords present here, they produce the sound. Sound travels through a medium, gas, liquid or solid. It cannot travel in vacuum. The eardrum senses the vibration of sound. It sends the signal to the brain, and this process is called as hearing. Then the number of oscillations or vibrations per second, we term them as frequency of oscillation. The frequency is expressed in terms of hertz. Larger the amplitude of vibration, larger is the sound or louder is the sound. Higher the frequency of vibration, high pitch or shriller is the sound. Unpleasant sounds are called noise. Excessive or unwanted sound, they lead to noise pollution. Attempts should be made to minimize this noise pollution, and plantation of trees is one method to reduce noise pollution. So that was it for this chapter of class 8, chapter 10, sound. Thank you so much for watching today's video. Please don't forget to like, share and subscribe to the Bodhi Academy.